Hey everybody, this is Mrs. Ewald signing in. And first off, let's give a big woohoo for the last podcast of Chapter 7, Unit 7 with solutions. It's been a long road, so this is the last one. Then after this, you could take a breath and just study. But this should be really, really fast. I'm going to go through an example with you, and then you're going to go through an example on your own, and you better make sure you have that example in class to show your teacher no matter what. So you want to try it, try to figure it out. You can do it. Stay positive. So molar mass determination is the last bit of this. And all it is doing a little bit of a continuation from freezing point or boiling point. I'm going to give you examples today for freezing point depression and how that's used then to figure out a molar mass of something. So that's going to be your unknown. And I try to give some examples here today that are very realistic and applicable, so maybe you're interested in one or the other. The first one, reserpine, is a natural product that actually comes from the roots of a shrub. And just so you know, this is just some knowledgeable information, so you could bring this up on your next hot date. Something like, it was first synthesized in 1956 by a Nobel Prize winner, R.B. Woodward, and it is also used as a tranquilizer and a sedative. So that's pretty interesting, huh? So anyway, when you have 1 gram of reserpine dissolved in 25 grams of camphor, so you want to identify this here is going to be our solute, and we are dissolving that into camphor now, which is going to be our solvent, so it's different from water. They tell you that the freezing point depression is 2.63 degrees Celsius. So that's how much it was depressed. So that would be your change. So this here is going to be your change in temperature. They also provide to you the Kf of the camphor, which is 40 degrees Celsius per mole. And we want to calculate the molar mass of the reserpine. The first thing we're going to need to do, though, is calculate mole. So let's figure out here everything of what we have. And we're going to be using delta T is equal to, and I should probably make that a capital T to stay consistent, equal to Kf times mole times Van Hoff factor. Now, Miss Heaton went through and showed you how the Kf, she gave you a negative value just to remind you to subtract. And I'm actually going to keep this as a positive value for this example. You could do it either way. Again, the way she did it, you would end up with a negative value to remind you to subtract from your normal boiling point. In this case, I'm just going to leave it positive for our purposes here. So our delta T is 2.63 degrees Celsius. The Kf is 40 degrees Celsius per mole. And then the molality, remember molality is moles of solute, and we have 1 gram of reserpine. And the thing is that we don't know, obviously, what the molar mass is. So what we need to do first is solve for mole of that reserpine. So mole of solute. And we are given a mass of the solvent, which is 25 gram. So we could quickly change that to 0.025 kilogram. And then the Van Hoff factor for this, reserpine, it's a natural product. We're going to assume that's organic, and so therefore it is not ionic. So we're just going to leave that as 1, and we'll leave it alone. So the next thing for us to do is calculate our mole. To do that then, you are going to simplify this down. And so you'll end up then with 2.63 equal to 1,600. And we're still solving for mole. Okay, so let's multiply, so you're going to divide that. So you take 40 divided by 0.025 to get 1,600. And then you're going to divide this out to get your mole. So you will end up then for mole, a long number, and we're just going to keep it, 0.00164,375. And if you remember, molar mass, the unit, is equal to gram over mole. Now, we are given 1 gram of reserpine. So that is our mass given of our solute, and we calculated our mole, so we're going to plug that in here on the bottom. divide that out to get our molar mass, which is approximately, keep 3 sig figs, 608 grams per mole. And then just make sure that that makes sense. So again, what we're doing is we're using freezing point depression in order to calculate first our mole, since we don't know how many moles of reserpine that is, and we're solving for molar mass, but we are given the mass of it. So I calculate my moles first, so by simplifying that to get to this, then I'm going to take the mass provided divided by my mole to get my molar mass, and then we're done. So the next one I would like for you to do on your own. And another really exciting one, you have a chemist trying to identify a human hormone by determining its molar mass. So it gives you the mass of the sample, 0.546 gram. So you're going to use that in your second part to get to molar mass. And it gives you the mass of your benzene, which is your solvent. And it also gives you the freezing point depression, so your delta T, which is 0.240 degrees Celsius. We also provide the Kf of benzene. So you're going to do everything just as you did in the first example. I'm going to tell you you're going to want to solve for mole first of your hormone, and then take that divided by, you're going to take your mass provided divided by your mole to get to your molar mass. And just make sure that it seems like a reasonable number. So that is about it for molar mass. This is Mrs. Ewald signing off, saying, yay! You're done with solutions. Peace out.